Okay, here we go. So we're going to look, like I said, more at these trig identities, but we're going to be verifying today. So we're going to be told that two things are equal, and I'm going to kind of show that it is so. And the directions will be something along the lines of verify the following. Actually, we'll just say that. We'll just stay there. I don't need to. That's right. So we'll just say verify the following. Sorry, the inflection there indicated that I was kind of seeing more. I'll write up here on the board our Pythagorean identities, because maybe we go to the least familiar, one of the ones with which we are least familiar. Okay, remember that these will not be given to you tomorrow, the Pythagorean identities, so you'll need to have those down, okay? Oh boy. Okay. So here's our equation. Sine theta plus cosine theta times cotangent theta equals cosecant theta. All right. Now, our goal here is to show that these two things are equal. So we need to manipulate. Okay, we need to manipulate. All right. What you cannot do here, what you cannot do, can't do this, okay? You cannot use the algebraic property, okay? You cannot use the algebraic property of doing the same thing to each side, right? And that's not very official mathematical language, but that's, you get the idea, right? So normally when we have an equation, right? The equation, in an equation, we are told these two things are equal, right? And then because we know that they're equal, we're allowed to maintain that equality by doing the same thing to each side. That's how we solve equations. That's why equations work the way we do when we solve an equation. As long as you do the same thing to both sides, if you start with something that's equal, then it will continue to be equal, again, as long as you do the same thing to both sides. Here, if we're trying to verify that these two things are equal, and this is like a little bit of like a philosophical like logic thing, idea. If we're trying to verify that these two things are equal, we can't use that they are equal to show that they are equal. Okay, it's like using the word in the definition, kind of, or something like that. You can't assume something's equal to prove it's equal, right? So when you do the same thing to both sides, you're assuming it's equal. So then how do we go about verifying stuff if we're not allowed to do the same thing to both sides, right? The idea is you pick a side, the left side, and you do things to that left side, in this case, to make it look like the right side. Okay, so we kind of do what we did here with our warm-up, where we simplified the trig expressions. Okay, so we treat this like a trig expression, and we're just going to simplify it to the point we can get it to be cosecant of theta, just like that. Okay, that's our goal. So, and I also recommend that you only work on one side at a time. So you could manipulate this side some, manipulate this side some, and then get the left and the right-hand side to match. However, that can be tricky. Okay, it's like if you work both sides, you can like sometimes make them go further away from one another than get them closer to each other. So I would recommend just stick with one side, and I would typically, the way these problems are set up, it's the left side that you want to manipulate to then look like the right side. Okay, so all that being said, all that preparation being said here, what would be a good idea here to go about with this? How do you think maybe we should start tackling this problem here? Any ideas? What's a strategy that we can use, that we used in the past? So, Adrian, what do you want to say?
You could make cotangent, cosine as your sine.
Okay, great idea. Let's use that same strategy of rewriting things in terms of sine and cosine here. Okay. Now, at first glance, right, and maybe Adrian, this is why you're kind of hesitating. You're like, I don't know if this is going to make things any nicer or not. In fact, it looks a little more complicated right now. But let's kind of continue with this, right? So I've got, well, I can put these cosines together, right? This is really cosine theta over 1. And so I end up with sine of theta plus cosine squared theta over sine theta like this. Okay, and again, I'm trying to get cosecant of theta here. So I got this far. Okay.
You could wait that. It would have to be both squared if you're going to make it into a cotangent.
Right, exactly. Very good point there, Ro. Yeah, so just real quick, Ro was pointing out, she's thinking, oh, maybe we can make a cotangent squared. Oh, but we have a cosine squared and just sine here. So we couldn't make that a cotangent squared. We could break it back up into what we had right here. So I can make it cosine over sine and then cosine over 1. It would go right back to here, though. It's kind of not what we want to do here. So let's keep in mind here what our ultimate goal is. Our ultimate goal is a single term, cosecant theta. How many terms do we have over here? 2. So we probably need to combine these things into a single term.
If you minus the sine.
Well, remember, though, we can't subtract from both sides. We can't do this. We can't minus the same thing from both sides. So I could add and subtract a sign here, but we can't subtract from both sides. Because, again, that's assuming these things are equal. We don't know if they're equal yet. We're trying to verify that they are. So my point is, though, how might we be able to combine these two things? What do we need to combine these two things to get a single term? Not cross multiply. Common denominator, right? These are two fractions, right? This is a fraction over 1. This is a fraction over sine theta. So let's make this over sine theta. We'll multiply by sine theta over sine theta here.
So it's just something squared.
So it'll be sine theta, sine squared theta over sine theta plus cosine squared theta over sine theta. Now, are we starting to see something come together here? When we add those together, over just sine of theta, right? Okay. But it's a single term now, kind of. I mean, the sine squared plus cosine squared doesn't really combine together. But what is sine squared theta plus cosine squared theta? It's 1. Yes, it's a Pythagorean identity. So we get 1 over the sine of theta. And what's 1 over the sine of theta? Cosecant. Check. It's right. Okay? It does work. Will they ever not work? No. You will be given, yeah, you might think it like, Mr. Wood, this one can't work. No, all the ones that you'll be given will work. I won't give you an impossible one. That would just be, what's the point of doing it? Great thought. I don't know. So you don't think there was anything to figure out from where we started to where we ended there?
No, because it didn't gain anything. In the end.
In the end, we didn't get anything.
We were like, oh, this equal sign makes it an equal sign, but we already knew that the equal sign was going to equal it.
True.
Like, this is basically training for figuring out if the equal sign is true or not.
Essentially,
but
yeah.
if we already know that the equal sign is true, then there's no reason.
We wanted to verify that it was so.
Why don't you? Yeah, you can verify something that might not be true too.
That's right.
You can verify.
But for these, we're going to give you ones that are true. We're going to give you ones that
That
work.
makes no sense. Well, maybe.
If you want me to throw in ones that don't work, then that would make it a lot more complicated. These are already hard enough, I would say. I would say these are already hard enough. And that's really just what we're interested in here, is just building up our manipulation skills, Ro. Okay. But I see what you're saying. Okay. Secant theta minus tangent theta times cosecant theta plus 1. Does that equal cotangent theta, right? Or let's show that it equals that.
There's an elephant in the room.
Yes, there is an elephant. We have to address it. Okay, so ideas here. Yeah, we can multiply it. Okay, you want to multiply first? So, like FOIL you're saying, right?
No, don't have to look.
FOIL it out? Okay, so here we go. So first will be secant theta, cosecant theta. Outer will be plus secant theta. We're foiling this out. Binomial, binomial. So first gives us this. Outer gives us this. Inner. Yes, yes, because we have to show that this is equal to this. So
Shouldn't we have like done the thing with the reciprocal?
we're going to try this one. See how it works. This is not necessarily wrong. I don't know.
Well, now we can
It could work.
we can still do the thing with the reciprocal.
Right.
Can we do the easier?
But here's the thing.
That's not what
You guys aren't going to necessarily know what the easier way is. And I don't know if this is easy or not. We'll find out.
is close. You do know.
I have a way that I know works, but I don't know if this is better or worse. I will. So how about this? I will show you my way after we do this one, and we'll see if it works. If it's you guys like it better or not. Because here's the thing, Mr. Wade's not going to be over there over your shoulder, being like, "Oh, careful, don't go that way," you know, kind of thing. You're going to have to figure it out for yourself. Okay? So this is practicing like we're going to play. Right? This is what you guys are going to experience tomorrow and today after we try and get some practice. Yes, bro.
So, do we do the, like, can we do the thing with whole turning secant theta, with turning all the values into their things?
So like with sine and cosine, you mean? Let's rewrite everything in terms of sine and cosine here. So secant is 1 over cosine. Okay, and then cosecant is 1 over sine. Okay, not looking promising right there, but that's okay. We can't simplify anything right off the bat. We have plus 1 over cosine. Minus tangent is sine theta over cosine theta. And then cosecant's 1 over sine theta. And then tangent again is sine theta over cosine theta. Okay, hope I did all those correctly. Yes.
So
Okay.
got things. Like, yeah, you can turn the
Ah, yes, we could.
and like the plus the 1 over cosine minus sine over cosine.
Here's the thing, though. So,
But
yes.
it's multiplied, so you can
So we could cancel out the signs right here, for example. That does cancel. However, if you look, how many terms do we have here? 4 terms, and we want to simplify it down to 1 term. So we're going to need to actually combine all these terms together. In order to combine them all together, we're going to need to come up with a common denominator again. And what is our common denominator going to be? Cosine sine, right? So we have 2 terms here that already have it. So we could cancel it out, Caitlin, but I think that might hamper us because we actually need that common denominator. Do you see what I'm saying there? But you're right, it would cancel.
I don't want sine to be on the
Okay,
front, it's
so we need sines for both of these terms right here. So let's go ahead and do that. So sine theta over sine theta there, and we'll multiply this one by sine theta over sine theta. Okay, so we've got 1 over cosine theta sine theta. Okay, plus, and this will be sine theta over cosine theta sine theta, minus sine theta over cosine theta.
Wow.
Minus sine squared theta over cosine theta sine theta.
It's almost like the way it's supposed to be solved.
Wait, that first one?
Which one are you asking about?
The first term, like
Right here?
No, the one right above it.
Oh, here?
Yeah, what does that say?
1 over cosine, 1 over sine.
Uh,
Because I changed the secant and cosecant to the reciprocal identities there. Okay. Now, yes, we see now what cancels.
Everything.
Sine theta over cosine theta sine theta minus sine theta over cosine theta sine theta. Those are exactly opposite, so they cancel out. They subtract and go away. Okay. What's left then, our numerator is going to be 1 minus sine squared theta over cosine theta sine theta.
Isn't that one of the things though?
Yes, it's a manipulation of our first Pythagorean identity, right?
Yeah.
What is 1 minus sine squared theta the same as? Cosine squared, right? If I subtract this, now, so again, I can do the same thing to both sides here because the Pythagorean identities we are told are true, we can accept to be true, right? We're trying to verify here, so you can't do the same thing to both sides. But here, Pythagorean identities, you can do the same thing to both sides. So cosine squared is 1 minus sine squared. So here, this will equal cosine squared over cosine theta sine theta. And how can we continue from here?
Wait, wouldn't it be minus?
No, if I subtract sine squared from both sides, I'll still have a positive.
Subtracting the sine squared.
Yes, sorry, subtracting the sine squared, because we need the 1 minus. So, how can we simplify from here? Jenna?
Can one of the cos on the top?
Yeah, we have cosine squared in the top, so that's 2 cosine times cosine, and the cosine cancel. So one of the cosines there will cancel out with that cosine. Cosine theta over sine theta, which is cotangent theta. Check. Verified. Okay. So there is no like this. So this can be uncomfortable for students sometimes because, especially, you have this goal in mind, and you're like, how am I supposed to get from here to there, right? Okay. Mr. Wade, just tell me what to do every time so I can do it. Because a lot of the mathematics that we do, right, in class is like, you see a problem, here's the procedure that you do, and then you get your answer, right? Well, here, we kind of flip that thing. We tell you what the problem is, we tell you what the answer is, but we don't tell you the procedure. And that's the trickier thing for students to figure out, right? Because it's uncomfortable. It's more, I don't want to say guesswork, but it's, well, I guess in a sense it is guessing, but not really. It's like educated guessing, right? But big idea strategies here, right? I would still recommend utilizing the idea of changing things in terms of sine and cosine, right? Because obviously that's going to help you get like terms, combine things together, and all that jazz, right? Also, keep in mind what your goal is here. Our goal is a single term, so we had to get all these different terms here together somehow, right? And so what does the math require of us in order to be able to get those together? Here, it was required that we got a common denominator, okay? And that eventually led to our goal there. Okay, so here's the alternative method that Samantha thinks I was holding out on you guys for. I don't think my method is that much better, but there's an alternative right there. Okay.
That's what I was gonna.
Is that right?
Wait, what is?
Change everything to terms of sine and cosine, very first step. Okay, it's a little messy. You still have to FOIL it out. Or no, sorry, you don't have to FOIL it out because you have a common denominator in the first term. You have to get a common denominator in the second one, and so it creates essentially, two things multiplied. You get cosine theta, sine theta, denominator. You have 1 minus sine times 1 plus sine. It's a difference, right? A minus b, a plus b. So you have the difference of squares there, and then you still get your 1 minus sine squared. You cosine squared, you cosine still cancel. So you can see like the last 3 steps of the same thing. The last 3 steps you still see. Yeah, when you have something minus something, and then that same something plus that same something, it becomes, when you FOIL this out, it becomes just 1 minus sine squared. Or if you just want to FOIL it out yourself, you'll see the middle terms will cancel.
I don't know. I like my way better.
This is the quiz and the test. This is the quiz. The quiz tomorrow will be problems just like this. I mean, there's 6 of them total.
Okay.
So we each do 2.
You can split them up, or you can also help each other out too.
That too. Yeah.
But I think the idea of splitting them up is not a bad idea, though.
Do you want to do it one at a time?
It is not time except you have the class period. So in that sense, it's time. All right, let's do one more here together, and then I'll give you guys one to try on your own. One more together, and I'll give you one to try on your own. Okay, here's one. Okay. trying to take that 1 over tangent x plus cotangent x and let it equal sine x cosine x. Okay. Again, you may be tempted here to be like, oh, that right-hand side looks much nicer. Let's go ahead and manipulate that to make it look like 1 over tangent
No.
cosine. But I'd say no. Thank you.
Why don't we just
So, thoughts here. How should we maybe start out?
the reciprocal of tangent x plus cotangent x? Just turn that into the reciprocal.
So you want to change tangent to 1 over cotangent, or you want to change cotangent to 1 over tangent? Which one do you want to use? Well, yeah, it's either way. Which one would you like to do?
How about
Change cotangent to 1 over tangent?
yeah.
Yeah, okay. So we're going to change here cotangent to 1 over tangent. So we have this now, right?
And then you can multiply, because now it's basically tangent over 1.
Right, it's tangent over 1.
You can do the,
Get a common denominator?
yeah.
Common denominator, we want to combine these two fractions together. And again, you can kind of see a need for it here to get these two terms together. Why do we see the need for it? We can see here we have one term. Again, we kind of have two terms. We have these things split up by addition. We want to somehow get them all together as a product, right? So we end up with like this. So yeah, let's multiply by tan x over tan x. Okay, and so you get 1 over tangent squared x over tangent x plus 1 over the tangent of x, which is really 1 over tangent squared x plus 1 over the tangent of x. Okay, like so. Okay. Can we also, just because we have this like fraction within a fraction, can we change this, instead of doing 1 divided by a fraction, can we just multiply by the reciprocal? Is that okay?
We can do that.
Just make it the reciprocal. So let's just make it tangent of x over tangent squared x plus 1, like that.
Yeah, that's
Okay, that makes it a little bit nicer just because I don't have to keep writing all that compound fractions and fractions. Okay. Secant squared is what tangent squared x plus 1 is.
Do we go alphabetical steps?
Yep, where would you like to start?
Um,
Here, I'll go back at the very beginning.
1 over tan squared x over tan.
Right here?
Up 1.
Up 1 here?
Yeah.
Okay. So you're okay up to this point? Or you want to go one step back, and how do we get from here to here? You're good to here?
Yeah, I just don't.
Okay, so at this point, we've got a common denominator, right?
Yeah.
Okay, and so because they're common denominator, we can add the numerators together. But they're not like, so we just write tangent squared x plus 1 and put it all over the tangent x there. So far, so good. And then because we have 1 over that quantity, we can then, instead of dividing by this fraction, we will multiply 1 by the reciprocal of this, which is just going to be this. Okay? And then a few of us pointed out, okay, a few folks found there, tangent squared x plus 1 is the same as secant squared x. That's one of our Pythagorean identities. Right here. Okay. How should we further try and simplify this then? How should we proceed now? Okay, turn secant squared into 1 over cosine squared, and probably turn tangent into sine over cosine, right? Okay, so let's do that. So tangent is sine x over cosine x, all over 1 over the secant squared of x. Another compound fraction, right? But again, instead of dividing by a fraction, we can multiply by its reciprocal. Whoops, I put that secant squared, it should be cosine squared there. My bad. Okay, sorry, 1 over cosine squared. So instead of dividing by 1 over cosine squared, we will multiply by cosine squared. Okay. And then at this point, what can we do? Eliminate the cosine x, eliminate one of the cosines there, and so we have sine x, cosine x, all over 1. And there it is. Okay, verified. Questions on any of that? Now, did anyone want to convert this to sine and cosine first? Right off the bat?
No, because then that would get rid of the thing.
It's actually not that bad if you do it. I'll just show you here real quick.
You can't see.
Okay? So change it to sine and cosine. Get common denominators here. So this denominator is missing a sine, this denominator is missing a cosine. So you end up with sine squared over sine x cosine x plus cosine squared over sine x cosine x. And it's like 1 over that, of course. And then when we add these together, we're going to have sine squared plus cosine squared, but what's that equal to?
Sine squared plus cosine squared.
1. Yeah, so we have 1 over sine x cosine x. And instead of dividing by a fraction, you can multiply by the reciprocal.
Sine x over 1.
And then there it is. Much more quickly, right? But that's okay. We're going to go different ways there, okay? We're going to go different ways. What's more important is that you get to the end goal, right? But there's another way to think about it.
People normally do well on this quiz.
What's that? If they need me to sign it, you can come back, though. But they're not going to need me to sign it. So, okay. Questions? Sorry?
People normally do well on the quiz.
Do people normally do well? I mean, I get roughly, I mean, it's hard to say.
Do we put all of our names on the on our quiz?
Students do well. Some students don't do well. It's like every other quiz that we do.
In the name thing, do we get graded on like our groups or just like
You will hand in one paper for the entire group.
Oh.
I will give you each a copy of the quiz, but I'd like one master
So we put our names on
paper.
all names on
Mm-hmm.
Alright.
Yes, yes. And yes, that means one person could be carried by the entire group, or that means one person could carry the entire group kind of thing. I get that, but, you know, so it goes. Choose your groups wisely. What's that? Do you get points for what? Yes. Yes, there are like pity points, I guess I'll say. But it's not going to be like, you know, if you put IDK after your first step, that's not trying. Okay.
No. What if you just put the struggle tomorrow?
It's tomorrow, yes. So, since it's tomorrow, we should probably practice some more. Here's one for you. Sine theta over 1 plus cosine theta plus cotangent theta. I want you to show me that that equals cosecant of theta. Okay, let's go ahead and give this one a try.
Let's say 1 plus cosine.
Yes, 1 plus cosine theta. Okay, there's one for you all to try. Give her a try. I guess I should try it too. Obviously, you just can't make these up, right? Because, I mean, to just make one up would be... You'd have to figure out if it's true in the first place. Oh, nice. Cool. So if you multiply by a cosine theta, if you had cosine in the numerator, right, and you multiply cosine theta, it would be cosine squared theta plus cosine theta. So keep that here.
It's not squared. Nothing is squared.
Nothing is squared, correct. Okay, great first step. Yeah. Okay. Right, you can't add these because they don't have what? Right, but you can see here that our goal is one term, so you probably do want to be able to add these together. So I suggest you do the common denominator. What is this denominator missing that this denominator has? What is this denominator missing that this denominator has? A sum. So you want to multiply the top and the bottom by sine theta over sine theta. So you're just multiplying by 1. And then what is this denominator missing that this denominator has? The 1 plus cosine theta. So you have to multiply top and bottom by 1 plus cosine theta there. Okay? Then distribute combining terms, etc. Yes, although I would not distribute this out. I would leave it undistributed there. Because you have in the numerator, you have a sine squared plus a cosine squared, right? Numerator, 1 plus cosine. Yep. So you can't cancel these things out like you did right here because of the addition. So if it was 1 times cosine theta sine theta and it was 1 times that, then you could cancel, but since it's got the addition, they can't like cancel out like that. So we go back up to here what you started with right here. So this here is looking distribute let me see this here.
But I still got this cancel test.
Leave that as sine squared. Don't rewrite it like that. And plus it would be actually this, I mean if you're gonna make it if you're gonna change it from sine squared to this, using like the Pythagorean identity, it actually should be 1 minus cosine squared. Right? Sine squared would be 1 minus cosine squared. Because you look at your Pythagorean identities there. If you've got a sine squared, you have to subtract a cosine squared over even sine squared by itself. But I actually don't do that. Leave it like this. I think I see here. Yes. If you're gonna so you multiply this one by 1 plus cosine theta over here, right? Right, okay, my point is so the denominator this denominator is missing a 1 plus cosine theta. Right? So you multiply the top and bottom by 1 plus cosine theta. Okay, when you do cosine theta times 1 plus cosine theta, you do cosine theta plus cosine squared.
Unfortunately, you still have to dress up. Wait. You can incorporate.
See what I'm saying? Here, may I see your pencil real quick? Sorry. Just write it.
Oh, goodness.
Could you come check my, I have a question.
Right, you're multiplying by cosine theta plus whatever cosine theta.
So basically this, right? So I broke everything down for you.
Over here,
Common denominator.
you want to multiply by sine theta.
And I have to get
So what you're this denominator means a sine theta to be what? This denominator means a cosine theta plus 1 to be like that.
But then, and that's still the denominator, but I don't know where to go from there.
Oh, I see. Oh, okay, so it's like flipping around on me. Okay. I see what you're saying.
That's a plus.
So, oh yeah, well you did. So Yeah, get a common denominator. Don't distribute your sign. Don't keep your sign undistributed. Just make sign times 1 plus cos. Like back when you had a denominator, you have 1 plus cosine. Which you can't do anymore.
What do you mean?
In your denominator, you have a sine common factor.
Wait, so the sine squared.
Factor your sine theta out of your denominator. Yep, like that. 1 plus cosine. That is the exact numerator that you have.
But you're just
Your denominator canceling 1%.
oh my gosh.
You were almost there.
Okay, so I got the common denominator, and I got
Yes.
what? Then I'm confused. I'm still trying to explain.
You can't cancel the cosine out.
Okay.
No, like not
And
And you
imaginary.
can't cancel the sine out.
Okay.
You're right. So rewrite everything without the cancellation.
So I was right? No.
Yeah.
I changed all this. Okay, cancel. Was I on the right track? Have this.
Okay.
Right. And what is sine squared plus cosine squared equal to?
Wait, what?
Your numerator. Thanks.
Wait, sine theta plus cosine.
Well, wait a minute. I'm dominating right. You haven't done GCS at all? I haven't done GCS at all. Remember, I took the extra day to do
I thought you just needed like an extra 20 minutes.
No. Okay. I didn't know. I didn't give the quiz until Friday.
Gotcha. Gotcha. Okay.
So those
So you guys did GCF from just from like so what did you guys do? Just GCF?
GCF from a college.
Okay. Like trying to be like comment like just run along everything. Did you do like did you have like write out all the
I
packages?
wrote down my middle doesn't
Okay, 1 plus
anything.
I just pull things out.
I have to find a little more
side is 1 plus
lower.
beta.
No, I get you, and I think that's part of what I'm
That
gonna do. At least to start out, and then I'll like get some of the kids like okay. And you're just making up GCF problems off the top of your head and stuff like that, right?
Yeah. But now you can use those as reference.
Right. So you guys are just doing more GCF today.
For like the review for like 20 minutes.
Okay, and then you're doing the factor by grouping, which is essentially GCF. Gotcha. Okay, I could maybe catch it today.
We'll see.
And then tomorrow is grouping again?
Yeah.
Okay, so sorry.
So you can get caught up.
You're doing this today, you're doing this today,
Yeah.
and then that's tomorrow. Thank you.
Mr.
Thank
Reed,
you, thank you.
And you.
Mr. Wood, am I on the right track?
can you do that?
Yes.
Wow.
Sorry, Will, you had a question?
Yeah. What is happening? Oh, that's why I got it.
Hey.
I feel like I did. It's like so bad, yeah, we were so close.
Right, but I don't change it to sine. Leave it sine squared.
Why? It's okay.
Because you did sine squared plus a cosine squared, which is just over 1.
What do we do?
And then
We're gonna beat the Saints, and then we're gonna this team going into the
so when you roll, okay, so there should be no plus 1 here. You don't need that. Plus 1. So cosine times plus cosine will distribute, leaving you with cosine squared plus cosine.
You guys lost the ground. You guys think first thing is
Right, so distribute that you cosine squared plus cosine. And so then you got your sine plus cosine. Sine plus cosine, that's 1. You got 1 plus cosine, which you cancel with that 1 plus cosine. Did you guys get things right?
Can we start the whole one?
That's 1. You get 1 plus cosine, then things will cancel. You have a 1. Oh no! Let me see what I've got. I don't know if I do. Did you find something? Or you want me to give you something? These were given to me as a joke present. They're like, you know, like what birthdays is age and child versus what their
Yeah, I don't think I got a mint. I don't have a mint. Okay. So let's go over this one. Oof. Okay, well, we'll catch up to you, Samantha. Okay. So there is our manipulated, okay, turning into sine and cosine. And then hopefully it's also pretty clear here that we should probably get a common denominator, right? So this denominator is missing what?
But what about this guy?
A sine, right? And then what's this denominator missing? A 1 plus cosine. So we're going to multiply the top and bottom by 1 plus cosine theta. Okay? So sine times sine, sine squared. Sine times 1 plus cosine, sine times 1 plus cosine. I'm not going to distribute the denominator. I recommend you don't either, okay? Just because things might cancel. All right, and then we will distribute the numerator here, though. Cosine theta plus cosine squared theta over sine theta 1 plus cosine theta. Okay. So we're going to add our numerators here because we have our common denominators. We're going to add our numerators, but we can see right away we're going to have a sine squared plus cosine squared. What is sine squared plus cosine squared? It's a 1, right? So we get with 1, we end up with 1 plus cosine theta over sine theta times 1 plus cosine theta. Okay? And 1 plus cosine, those cancel. And with 1 over the sine of theta, which is cosecant of theta. Check. Okay? There it is. What's that?
That's a bad check.
That's a bad check. Opinion noted. Okay, so with the rest of class, I recommend that you practice, and I've got the practice posted to our Google Classroom. Okay? The practice